students of Master's second year. Our course is Physics 571 General Relativity. I have already taken 3 classes with Zoom, but that classes were not any suitable because the Zoom software is not suitable for taking a course like General Relativity. So I took the course to again video lecture. So today, whatever I have learned before, learned. Today we shall discuss gravitational lensing or gravitational red shift. So what is gravitational red shift? Say, here is the earth and here is a building. In this building there is a lift and the lift is falling downward. So, as I have told you in the last class, a freely falling elevator is an inertial frame. Now, here is a inertial observer. He sends a light toward the ceiling. The lift is of length h. The lift is falling and the observer or experimenter within the lift or elevator sends a light pulse from the center of the floor, which moves upward to the ceiling of the lift. So actually, initially the frequency of light here nu naught. Inside the elevator or lift, the observer sees nu naught. He is inertial observer. He will see no shift in the frequency as the lift goes down. But say there is another observer. There is another observer who is observing this from the earth. This is called bystander. Bystander. He is looking, he is experimenting from outside the elevator. Now, although the observer within the elevator does not see any change in the frequency nu naught, because he is inertial, the light and him, these two, the observer and the light, they have no relative acceleration. Now, this bystander sees this is accelerating downward. So, the bystander will see in a non-inertial point of view. Within the elevator, the observer will see inertial point of view, and outside the elevator, the observer will see in a non-inertial view. Okay. Say initial velocity of elevator is V when the pulse of light was short. When the light pulse is triggered here, then the elevator has velocity V. Okay? So, as we know, if two observer has relative velocity, then there is a Doppler shift of frequency. Light wave suffers Doppler effect, sound wave suffers Doppler effect, any kind of wave suffers Doppler effect. And this is due to relative velocity between the two observers. Now, for sound, the relation between the source and the received frequency is one kind of formula. For light, the formula is nu 1. Why nu 1? Because actually it is nu naught. For the light, actually it is nu naught, but the observer outside will see nu 1 equals nu naught square root of 1 minus V by C divided by 1 plus V by C, which is approximately, because V is very small compared to speed of light, very small. If you do some calculation, say here, this is the square, 1 minus V by C square root whole to the half, 1 minus V by C whole to the half, binomial expansion, do binomial expansion, you get 1 minus half V by C. And the denominator 1 minus V by C whole to the power minus half, binomial expansion, minus half V by C. Then multiply, you will get 1 minus only half, only 1 minus 1 minus V by C. Approximately the frequency seen by the bystander at the moment when the light pulse was short is not nu naught, it is nu 1, and nu 1 is given by nu naught multiplied by 1 minus V by C. Okay, the light pulse goes upward, elevator goes downward. To think, light pulse goes upward, elevator goes downward. Since the elevator goes downward, its initial velocity was what? V. At the time when the light pulse reaches the ceiling, then what will happen? The elevator has more velocity than it was initially, because we know the famous formula V equals U plus G, right? Final velocity is initial velocity plus gt in gravitational field. Now, G is no problem, G will act here. What is T? Light pulse goes from floor to ceiling, the length is 8, and light has velocity c, the time is what? H by c. So you write H by c, and you write for u V. V plus G by C is the velocity, is the
power off.
velocity of lift at the moment of receipt of light pulse at the ceiling. Simple, very simple thing. When the light pulse is at the ceiling, the velocity of the lift is P plus H by C because it is falling downward. Now what will happen? Now we should write and next frequency. Now what is the frequency? Now what is the frequency? Observed by the bystander. Observed by the bystander, the velocity is now nu2 equals nu naught 1 minus v by c. V is what? V plus g h by c divided by c. Right? This is the velocity now. The relative velocity between the bystander and the elevator at the moment when the pulse is received at the top of the elevator, the velocity is this. The velocity by c, the simple formula. You can write this nu naught 1 minus v by c minus g h by c square, or you can write nu naught 1 minus v by c, nu naught 1 minus v by c. Let me see the formula. Plus or not plus, this is minus nu naught plus nu naught minus gh by c square, right? Plus nu naught minus g by c square. Now I do some trick. This is about nu naught 1 minus v by c plus nu naught 1 minus v by c multiplied by gh by c square. Why so? This term about 0. Since v is very small, 1 minus v by c is not about 1. V by c is about 0, 1 minus v by c about 1. So I inserted this. So next I can write nu 2 equals nu. What is this? Nu naught 1 minus v by c, nothing but nu 1. Nu naught 1 minus v by c, what is? Nu 1 multiplied by gh by c square equals nu 1 minus gh by c square. This is the final formula we were aiming at. At the time of transmission of the light pulse, the bystander sees frequency nu 1. At the time of receipt of the pulse at the ceiling, the bystander sees nu 2. Now, which is greater, nu 1 or nu 2? Nu 2 is less than nu 1. When frequency is less, wavelength goes higher, the light pulse moves in the spectrum toward the red end. So we say that this is red shift, and the cause of this is what? See, h is a just geometrical factor. H is a geometrical factor, the height of the lift. One, new one, these are the material. G is material. Because of G, the bystander seeing this Doppler shift, red shift. So it has to do with the gravitational field of the Earth. In other words, any gravitating body influences light and causes gravitational red shift. Okay, there is also blue shift. If the light pulse goes up, then it is red shift. If the light pulse goes down, it is blue shift. In gravitational field, if you go up, red shift will occur. If you go down, light pulse goes down, there will occur blue shift. Okay, so much for gravitational red shift. The next thing is, here in this formula, a hidden thing is there. What is that? That is Einstein's famous formula, E equals mc square. In this formula, there is hidden Einstein's famous formula, E equals mc square. In other words, energy and mass are same. You know, in special relativity, when you go to calculate E equals mc square, it takes 2-3 pages and time half an hour to 1 hour. But here in 2 or 3 lines, we will see that energy and mass are same. Say what? Mass and energy are same. Our formula is what? Nu2 equals nu1 1 minus dh by c square. Now come to the point. This is a lift. The bottom, the top. Say this is at height z1. This is at height z2. Potential is phi of z. I remind you, this is not potential energy, this is potential. If you divide potential energy by mass, you get potential. So, here the potential is what? Whatever it is, we know a simple formula. Potential energy at a height h is mgh. Potential energy at a height at h is mgh. Divided by m, what remains? gh. Now I can write phi of z2 minus phi of z1 equals gh, or phi of z1 minus phi of z2 equals minus gh, right? Z is at high position, so that is the high potential, it is low potential, so this is plus gh. Now you interchange the term, take this one first, then take it here, you get phi of z1 minus phi of z2 minus gh. So now we can write here we can write nu1 1 minus 1 plus phi of z1 minus phi of z2 by c square, right? Minus gh, we replace minus gh. We replace minus gh by phi of z1 minus phi of z2 equals minus gh. Now I can write this as nu1 plus nu1 phi of z1 by c square minus nu1 phi of z2 by c square. So we can write now, interchanging the terms, we can write nu2 plus the term nu1 phi of z2 by c square. On the right hand side, nu1 phi of z1 by c square. Was it nu1 or nu0? Nu1. Okay. Now here insert a term 1 minus gh by c square. Then nu1 multiplied by 1 minus gh by c square is what? Nu2. Why I do this? Because we want the relation important. Another thing, this can be replaced here because this is about 1. 1 minus g by c square. H is very small, g is very small, c square is even bigger and bigger and bigger. So this is about 1. So as I insert it here, nu1 minus g by c square becomes nu2. So we can write nu2 plus nu2 phi of z2 by c square equals nu1 plus nu1 phi of z1 by c square. Now I use not general relativity. You cannot blame me. I am not using general relativity. I shall use the theory before general relativity, Planck's theory. What is that? E equals h2. This is not general relativity. This is the quantum mechanics before, which arrived before general relativity. Okay, multiply h nu2 plus h nu2 phi of z2 by c square equals h nu1 plus h nu1 phi of z by c square. Okay, so what? This is energy E, energy by c square, energy E, energy by c square. So we can write E plus E by c square phi of z equals. You see this? So now concentrate on this term. What is this? It is the energy of the photon, internal energy of the photon. It does not depend on position or something. It is the energy which is inside it with the pulse, like a nu lambda equals c. Whenever you have nu, you have lambda, and it is nu lambda equals c. That nu is this. This is that nu. Multiplied by h, it is the E. This is the internal energy of the photon. Photon's own energy. Now, what is this E by c square? What it is?
Mass.
High mass. Because this is energy, this term also belongs to energy. Now we know energy mgh. ठीक है सर? What is gh? This can be replaced by phi.
Potential.
potential. What remains? Mass, M. So we can write E by C square plus M. Or E equals M C square. This is the famous Einstein's formula of mass energy equivalence. What is mass? Is energy. Only described in different units. Mass has kg, energy has joule. Only this difference. You measure the two things in two units. Actually, mass and energy are same. And another thing, photon has mass, but this mass is not inertial mass. This is gravitational mass. This is gravitational mass. That means photon feels gravitational pull. Photon feels gravitational attraction, repulsion now. Repulsion is not there in gravity. Gravity is always attractive. So photon feels attraction of gravitational field. Our body, any body that has mass can interact with photon. I'll give you a contrast here. You know neutrino. It does not act with anybody. And there is action with somebody feeble. And nowadays we call dark matter, dark energy, right? Dark matter, dark energy. Why they are dark? Why they are dark energy? Because they do not interact with any other body, even not with light. Even not with light. So the thing cannot be seen by looking with electromagnetic wire, light paths. So that becomes dark matter. Anyway, photon is quanta of light, and it feels attraction of gravitational field. And another thing, mass and energy are the same thing. Okay, next, simple point. Einstein thought all of this, and he took a resolution that gravitational field cannot be considered as a force field. Gravitational field cannot be considered as force field. Why? All bodies accelerates at the same acceleration. If it was a pure force, then one body will feel some more, one body will feel some less. But everybody feels the same acceleration. So gravity cannot be said as a force. It was Einstein's initial supposition. He said a gravitating body, that means a body with mass. A gravitating body influences the space-time around it. A gravitating body influences the space-time around it and makes it curved. Particles follow those curved paths. They do not find any force. They do not find any force. They are free particles. They see the path, which is the path here. That means you can, if you draw, this is the path in the outside a gravitating body. A particle here goes in this way. Not because of force, but because this is the curved path here. These things are called geodesics. Geodesics are as straight as possible line. We know straight line. Straight line does not bend. Geodesic can bend, but it is most straightest it can be. That means what is a gravitating body produces a curved space-time around it, and particle follows geodesics. In other words, geodesics are those which is followed by free particles in gravitational field. And there is geodesic equation. We shall see this in the later lectures. So, what is the equation? The type of equation for these particles in gravitational field are like dp by d tau equals 0. Why? Because Einstein's supposition is these are free particles. There is no force acting on the particles. They are free particles following geodesics as straight as possible path. Free particles following as straight as possible path. Geodesic. So there is no force. If there is no force, Newton's second law, go back to Newton's second law. dp by dt is f. F is 0. dp by d tau. Why we like tau? Because in relativity we have no choice but to use the proper time. We have no other time available for this particular. So p is the momentum, tau is the proper time, dp by d tau equals 0. This is not exactly the law. This will be more complicated when we go into the details of the general relativity. This will be defined. But the concept is the force law is dp by d tau equals 0. Conceptually, the force is there is no force. There is only curved space. Particles follow geodesics. That means as straight as possible path they follow. With this supposition, Einstein went ahead and found the theory of general relativity. In the next class, we shall discuss special relativity, because special relativity is also important for us. In the previous class, I told you, in a freely falling laboratory, inside that laboratory, the laws of physics are those of special relativity. So we have to learn special relativity also. You already have learned special relativity, but I shall review the special relativity. Okay, students, to this much.